Our learning goal today is the third thing that we need to learn from this lesson, and that is that you can evaluate a function for given values of the domain. So in other words, they say, when we give you this domain value, evaluate this function, find the f of x value or the y value given this particular domain value. So let's first start by writing that in our notebook so we know what this is. This is lesson 3.3. Evaluating functions. Okay. Lesson 3.3, evaluating functions. Have that title at the top of your page. Okay. And then let's put that we're going to first start working with page, we're going to actually do the check it out problems. So page 181, we're going to do the check it out. So again, in your notes, it's nice to know where did this stuff come from. And we will be doing the ones at the bottom of the page. So if you want to make that little note, it's at the bottom of the page. Okay? So there are more than one set on that page. We're actually going to do the ones that go with example 4. So we're going to do 4A as our first one to start with. Okay? So first of all, we are given the function h of c equals 2c minus 1. First of all, what do we call that when the equation is written in that form? What's that called? H of c equals 2c minus 1. What's that called? Austin?
Function notation.
Function notation. Function notation. Now, what's the independent variable in this one? C. This time it's not x, is it? It's c. H of c. H of the function evaluated at the independent variable. They're telling you the domain values are not x values this time. They are actually c values. So let's first of all write down our function h of c equals 2c minus 1. And we are supposed to evaluate that for two different domain values, for c equals 1 and c equals -3. So we are to evaluate that given function. And I'm going to show you how you should be writing it, like properly, okay? How we would show what we're doing. So we're first going to take the one where c is equal to 1, our domain value of 1. So we show in place of c, we show h of 1. We're saying we're evaluating the function with our independent variable having a value of 1, and then we substitute it in for c. So it's not like we're really substituting it in twice. It's what we're saying is I am evaluating the function for 1. And when I do that, I have to substitute it in anywhere the independent variable is in the function rule. Okay, so now we have h of 1, also known as what? Y, or h, yeah. Y, well, h is kind of like the function name. And this one we don't really know if they have a different name for y, so we're just going to say it's really like we're finding the y value. We're finding the range value, aren't we? Okay, so h of 1 equals 2 times 1 is 2. So our function evaluated at 1, the value is 1. 2 take away 1 is 1. Okay, you do it for -3 now. These are the steps you need to show. None of your assignments are that long that you cannot show this properly, okay? So now you are to evaluate the function for -3. What's the range value given the domain value of -3? What do we get? Look at this. See if I have it. Yeah, I'm getting it from you. What is it? Given the domain value of -3 for this function, what is the range value? -7. Why do we have to whisper that? Is it a scary number? So in reality, what we have, in both of these cases, we have found a couple of ordered pairs for the function h of c equals 2c minus 1. So when we are evaluating it, In fact, let's just do that. Let's just show that what we really just found is we have an ordered pair 1, 1 here. The independent variable is always the x, not always the x, is always the first coordinate of an ordered pair. Typically it's x. In this case, it just happens to be c. And what would this one's ordered pair name be? -3, -7. So what we really found are a couple of ordered pairs. They could be in a table, they could be in a mapping diagram, they could be in a graph. All 4 ways that we can show a relation. Okay. Okay, let's do the next one, 4b. Where we now have the function g of t. And typically these are the ones that they will use for naming functions. F, G, H, those are typically the ones that they stick with. And then if they need to name more functions, you know, kind of all within the same context, then they start using other letters. But so this one is saying the independent variable is what? What's the independent variable this time? T, and that's t. So we are to use g of t as our function. G of t equals 1/4 t plus 1 is our function. We are to do this one for t equals our domain values of -24 and t equals 400. Okay, so g of, what's going to go in here for our first one? G of what? -24. We are evaluating the function for the domain value -24. Now let's make this, you know, easy to do without our calculators. Okay. A, first of all, I'll write this down. G of -24. A positive times a negative is a negative. And 1/4 of 24 is really the same as saying divide 24 into 4 parts, right? So what is it? It's 6, and we already had decided it would be negative, didn't we? So the range value, given the domain value of -24, is -5. Ordered pair what? -24, -5. Okay, go ahead and do the other one. They're just way too next to you. 1/4 of 400. Much too bad. Okay, so our range value given a domain value of 400 is 101. And we have ordered pair 400, 101. So evaluating functions, we just have to be able to, first of all, speak function notation language, and just be able to do the substituting in, do the arithmetic using the order of operations properly. Anybody have any questions? Okay, then I want you to start, I want you to flip your page to 182 next, 182. And I want you to start reading the check it out problem in the middle of the page, check it out 5. That's the next one we're going to do. So would you start reading it to yourself? See what we're going to be doing first of all. first thing I want you to do in your paper, in your notebooks is put where are we at? We're at page 182 doing the checkout column number 5. In your notebooks, put that. This is where you would find the problem itself that we're going to work out. So everyone please put that we are on page 182. Check it out. Number 5. Okay. Even though they don't say to do all of these specific things, we are going to do some things that will help us set ourselves up for success for this one. We are going to decide what is the independent variable in this situation. Remember, the independent does what? What's its role? Is it the bystander or the authority figure? The authority figure is the one in control, right? Okay? And the dependent is like, okay, fine. Have it your way, I guess this is what I get out of it. So in this situation, what's our independent variable and what's our dependent variable? Those are the two unknowns, kind of like, or in some cases you might actually know them, but they can be represented by different things. So what's controlling what in this situation? What's going on even? Because they want us to find a reasonable domain or range, don't they? Isn't that kind of what they want us to do? Okay, well, what's going on? What's this about? How many trucks are going to go out to shovel snow on those poor guys that are east of us getting it? What's it about? What?
Space.
A space heater. Oh, okay. A space heater. Oh, like it's something funky like a spaceship and it heats? Or?
No, it's a heater.
It's a heater, like for a room where you live in North Dakota and you need to warm it up. Okay. So this space heater. Well, what about this space heater? Is it on wheels or not? Or?
It has 3 temperatures.
It has 3 temperatures.
Yeah.
Okay, what are they? Do we know?
No, goes up 500 watts each time.
But it does go up 500 watts each time. So there's 3 different temperatures that it can be set at.
Mm-hmm.
Okay. What else can you tell me about this? Okay, well, can you figure out then what's the independent variable in this? What can be controlled? The setting number, yeah. The setting number can be controlled. So that's what we're going to put first of all as our independent variable is our setting number on this heater. And we don't know if it's on wheels or not. What would the dependent variable be, or the output? Once you set that heater on something, what would be the output? The temperature, well, okay, in what? In watts. Okay, so would it be, so we could just say that the dependent would be the temperature in watts? Or would it be more like saying how many watts are used to make it that warm? Do you think it's really the temperature? I don't think so either. Because didn't I hear something about a 500 in here? Okay, so maybe what we should do instead is, I'm not saying that, because we usually measure temperature though, like in Fahrenheit or Celsius, we don't really talk about watts. So maybe the better thing to do is just say that the dependent is the number of watts. Okay? So the number of watts that are being kicked out of this thing. Okay? Well then, now that we've decided what the independent and the dependent variable are, the next thing we need to do is we need to decide what's the function rule here. What do we do to the independent variable? What do we do to the setting number to get the total number of watts? Remember, the setting number is in control. What do we do with it? Multiply it by 500, don't we? Yeah. So we multiply that by 500, so our function rule is multiply setting number by 500. So let's stick with function notation. What could our equation and function notation look like then for this one? Is there anything else in our function rule, or is our function rule that simple? Multiply setting number by 500. Okay? So what would our equation be? What would our equation be? I just worked with some 7th graders downstairs in period 1 that were far more responsive than you guys are. Benton.
F of x is equal to 500x.
F of x equals 500x. Okay, there's our equation. Well then, what we have to decide is what would be a reasonable domain for this. In other words, since we have to find the reasonable domain and range, we got to have some input values, don't we? So the first thing would be is figure out a reasonable domain for this. So what do you think we could use for a domain for this particular situation? What options do we have for setting number? So is this heater always on? Oh, we need to start with 0, don't we? Because can the heater be off?
Yes.
Yeah, so 0 would be off. And then we could set it at 1, we could set it at 2, or we could set it at 3 and no higher than 3. Is that how high it goes? Okay, so there's our reasonable domain. So now what we have to do is say, okay, well, using this, we need f of 0. I know this is like I could do this in my head kind of thing, but we're going to show what we actually do. F of 0, so f of 0 is what? What? 0, yeah. If it's set at 0, there's no heat being kicked out, right? If it's not on, that makes sense. Okay, so now we'll do f of 1. So 500 times 1. So our f of 1, when we have it at setting 1, the heater is kicking out how many watts? 500. Okay. And we just keep going. F of 2, because we got a couple more domain values. Guess I should start circling all of my results. So now we'll go up and finish what we have to, what was the other part of the question? We've already given the reasonable domain, we have to give the reasonable range. What's the reasonable range? Range is what? 0, 500, 1,000, 1,500. Any more? And this truly is a function, is that each domain value has exactly one range value. Okay, did they want us to do anything else in that one? Is that it? Find the reasonable domain and range. Okay, we did that. Find the function, we used that. Okay, questions? Okay, leave that out and open. That's going to be, for the first